integrating. And one of the things we want to emphasize here is that we're going to find the equation for A of the tangent line with the curve y equals ln x at the point e comma 1. That is a 1 and not an L. And the reason that's going to make sense is that at the point, so ln of x at e is equal to ln of e, and this is equal to 1. So on the function y equals ln x, when x equals e, 1 is going to be the value of y. Right, so now we want to find the equation of that tangent line to this curve. And so we've talked about two different ways of doing this. I'm going to start by finding the derivative of y equals ln x. And that's 1 over x. And so the derivative at at x equals e is going to equal 1 over e. So now we've got two different approaches. I'm going to use this one because I like it. So that's going to be the equation of my tangent line. And now I can simplify this a little bit. This will be y minus 1 equals x over e minus e over e. Y equals, so e over e is 1. Y is equal to x over e minus 1 plus 1 equals x over e. And if we want to make sure that the origin is on this line, well, what I'm saying is when x equals 0 is y equals 0. So the equation is y equals x over e. At x equals 0, y is equal to 0 over e equals to 0. That's the origin, so we're set. Very well, that should clarify for A. B, we want to show that the derivative of x ln x minus x is equal to ln x. So the derivative of x ln x minus x. So that's going to be the derivative of the first, which is x, times the second, plus the first, times the derivative of the second. And that covers the derivative of the product right there. And then that's minus 1. That is ln x plus 1 minus 1. And that's because this bit right here is 1. And I think we've established that very well. 2 points, fair enough. And now C. And C, you want to be a little careful, because at first it looks like it would be an easy problem of just an area under the curve, the area between two curves. But this ln x right here is only valid there. So the area under this curve doesn't cover the missing space. We've basically got to cover this triangle, and then from here to here, we can take the difference. So I actually wrote this out a little earlier. Okay, it's not as easy to manipulate as I hoped. Let's see, I'm getting there. Okay, here we go. Almost there. That's fine. So what I want to spend the time on here instead of rewriting the whole thing is that this piece right here, that's going to be this triangle there. Because I can't do this portion right here. That's the area between two curves. That's me taking the area under the tangent line, but over ln x. But that's only going to be valid from 1 to e. And I know that this is e because that's what they gave me. All right? From 0 to 1 right here, ln x does not exist. And therefore, I can't do the derivative of the integral of the top minus the area of the bottom. I have to do first the integral, or the area, from 0 to 1 of x over e. And then I can add this part right here. As we can see by the calculations that follow right here, we just kind of follow what's right there, we end up with what we were told to find. So we were showing that the area was 1/2 e minus 1. We get 1/2 e minus 1. And again, the difficult part, I think, right there, the part that can lead to confusion, there's two. One, you really want to see that this is when x equals e, y equals 1, and not an L, because that can create some real difficulties. The second one is this shaded area right here cannot be represented as the area between two curves, because from 0 to 1, it isn't actually the area between two curves. It's merely the area under the tangent line. Whereas from 1 to e, it can be treated as the area between two curves. And once you keep that in mind, then solving this problem becomes relatively simple. I hope this helped.